Greetings and welcome to ICS 613 Advanced Software Engineering. I'm your host for this semester, Philip Johnson, and I'm excited about this class. I really enjoy teaching it, and students generally have a lot of fun learning the material. So let's get started. The contact information, my email address, the website for the class, ics613s13.wordpress.com, office hours and so forth are here. Generally, anytime you see my door open, you can come by and talk. And of course, I do check my email quite frequently. I've been doing software engineering now, it turns out, for quite a long time. My first job was in the 70s doing business applications in COBOL for the Honda motorcycle company in Michigan. And back in those days, it was punch cards and all that kind of stuff. And I worked for Ford Motor Company in the 80s, working on one of the first microprocessors for engine control. In the 90s, I came to Hawaii and started doing research on collaborative software, computer-supported cooperative work, software metrics. More recently, I've been working in renewable energy, which is really fun out here in Hawaii. There's a lot of amazing and interesting challenges. So if you're interested in renewable energy, I'd be happy to talk with you about that. So in this class, we're going to try to learn how to build high-quality, large-scale software systems. And we're going to do that through this kind of organic growth process. So rather than kind of trying to spec it out all in advance and then build this giant thing, we're going to build something small and then try to grow it out and learn how you can actually do that without kind of going over the cliff and building something that has to be completely redone as it scales up. We're going to use a lot of tools in this class. That's going to be one of the funnest part, is learning all the different kinds of tools that are out there for building high-quality, large-scale systems. The other part of the class is going to be to help you develop a professional persona, something that can really help you get jobs or into graduate school or further whatever kind of professional development goals you have. So, what is, I said before we want to build high-quality systems. What is quality? And quality, of course, is, if you read Zen and the Art of Motorcycle Maintenance, which if you haven't, I recommend you do. Quality is a very abstract philosophical concept, and you can spend a lot of time thinking about it, but we're going to take a more prosaic approach to it. I'm going to say, for the purpose of this class, that what we mean by quality is that it's easy for users to use, it's easy for administrators to use, and it's easy for developers to use. If you can satisfy those three stakeholders and make their lives easy, then you've probably got a reasonably high quality system. And that's also usually pretty easy to do as long as the system is large. Where the problems occur is when the system as long as the system is small. The problems start to occur when the system gets large, and that's what we're going to be focusing on this semester, is the kinds of tools and processes you can put in place in order to make things still remain under kind of control as they get, or prevent them from getting out of control as the system scales in complexity and size. So there's a lot of tools that we're going to impose on you this semester, and initially you'll start to think, well, why do I really need to use this tool for this kind of small in-class project? And I think hopefully most of you will recognize that the tools really become more and more useful as you get involved in bigger and bigger projects. Okay, so I like to talk about the 3 prime directives of open source software. This is kind of my Star Trek component of the class. And these directives are that the system should accomplish at least one useful task, a new user can successfully install and use the system, and a new developer can successfully understand and enhance the system. Okay, when I say new user, or particularly new developer, I don't mean someone who's new to programming, but someone who's new to your system. So you might have an experienced Java developer who's new to using the system that you've produced in the class. You want to create a system project in such a manner that someone new to your particular domain, your particular system, can jump in and make progress on it quickly. And that's, a significant quality objective. Similarly, someone who's not new to using computers, but new to your particular software can get started on it quickly. And then finally, that it just does at least something useful. Okay, start somewhere with something that scratches somebody's itch. Okay, so the reason why we have this prime directive 1 is because no system is ever really complete. There's always going to be other things that can be done to it, so we just want to make sure that there's something of interest in that system and then create a process whereby incrementally new things are being added over time, maintaining quality at all times. And so in order to do that, we're going to develop in this class a bunch of standards for user interface, documentation, and so forth that's going to facilitate this. And we can't assess this prime directive ourselves. We need the end users to say to us, yes, I tried to install this system and it worked out for me. The second prime directive is that that a new user can successfully install and use it. And in order to do that, we need to have enough documentation. In order to have enough documentation, we're going to have standards for what should be involved in the documentation, and external installers in this case will be the feedback mode that we have to make sure that we've satisfied this particular directive. Third directive is around developers, and again we're going to have standards which help us ensure that we're able to achieve this particular prime directive. The standards are going to be around coding, design, packaging, and so forth. And in order to understand whether we've achieved this feedback, again, we can't ourselves unilaterally declare that the third prime directive has been achieved. Instead, we're going to have to ask external developers whether or not we're able to successfully understand and enhance the system. Okay, so you can see in all of these cases for these prime directives, we need to have standards that help us ensure that we have a reasonable chance of achieving the prime directive, and then we need feedback from the community or the set of stakeholders that the prime directive is oriented toward to see whether or not the directive has been achieved. Okay. All right, so as I said before, standards are going to be important. In fact, that's going to be a big piece of the class, is learning a variety of standards oriented mainly around Java technology in this class. But in any Ruby, any kind of Python, etc., there are always standards. And so one of the things I hope you come out of this class with is the sense that when you jump into a new kind of technology or new programming language, you immediately start looking to see what are the standards for use of this technology or language, best practices and so forth, and how can I acquire the ability to conform to those standards as quickly as possible. Then feedback, we're going to acquire or request feedback from a variety of sources in this class. That's really the best way to gain insight into whether you're achieving any of these goals. And there's a bunch of different communities. Some of these communities are people, and some of these communities are tools. Okay, so we're going to integrate tools into our development process in such a way that we find out whether or not, according to the tool, we're conforming to standards or achieving certain kinds of quality levels. Here's the architecture for the class. We're going to start off with basic Java capabilities at the bottom. On top of that, we're going to build via a variety of tools, interactive development environments, more advanced constructs, coding standards, software review, build technologies, quality assurance, testing, and configuration management. On top of that, we'll start to get into process level things like agile development practices. We'll do some measurement, so you get a sense for what kinds of metrics you can use to better understand how you're heading. We'll do some web application development as a way of kind of bringing these things together, and then just as the maraschino cherry on the top of the class, if we have time, which I hope we will, we'll do a little performance analysis and concurrency. There are 3 texts for the class: Java in a nutshell, elements of Java style, and effective Java. And there's a couple options for how you can get them. You can either buy all the books at Amazon. That, as of today, that was about $90. You can rent access to the textbooks from Safari Online using their 10-slot bookshelf. And that costs about $80 for 4 months. And then you can buy the elements of Java style. That costs about the same. The difference is you're not getting dead trees. So it doesn't matter whichever way you want to do it. There's also some of these are available on Kindle, so you could go that route as well. The advantage to Safari Online is you can get access to other books as well if you want to. people often ask me, oh, Java sucks, I want to use Ruby or Python or something like that. And yes, in many ways, Java is quite inferior to these other languages. In fact, my favorite programming language is Lisp. But I think Java is a nice programming language to use in this class, particularly because it has a lot of open source technologies that are designed for use with it that enable you to understand many of the state-of-the-art concepts of software engineering without having to pay a lot of money. Okay, so I think Java is a good choice for this this class, and you'll, after 4 months of using it, you can go on to look at some of these other languages, and hopefully you'll have some insights into missing pieces, tools, technologies that you'll want to incorporate into those other environments. And of course, when you go to those other environments, you'll start to say, gee whiz, man, this feature of Python is super cool. Why didn't we have it in Java? Hopefully in your comparative programming language class, you'll get a sense for the kinds of features that are available to a language like Java and not available in a language like Python, and vice versa. And it's a very interesting issue, because there's basically always going to be trade-offs in the design of a programming language, which makes certain things easy and certain things more difficult. Okay, for this class, graduate level class, software engineering, I expect you to be able to program in Java pretty well, or else come up to speed with it really quick. So if you're an accomplished C++ developer, not much experience in Java, then I expect you to work hard the first couple of weeks of the class to get up to speed using Java. And if you can't kind of swing with that, then you should think about dropping the course and getting some experience in Java before you come back to it. Development environment, you can use Unix, Mac, Windows. XP Pro 7 are for sure okay. The older ones are not okay. I don't know about Windows 8. I don't use Windows personally anymore. I used to, but I just finally decided to stop. If you're using Windows and you're using XP Pro or 7, you should be fine. You're going to need a lot of time. Okay, I mean, this class is just one of those classes where you're going to have to struggle with learning a lot of new things, and learning a lot of new things. None of the things that we're learning in this class are rocket science. They're not that hard, but they do take time, because you're going to get into trouble. You're going to have errors that you don't understand. And if you get started early, then you can send email to the mailing list, you can talk with your fellow students, you can resolve all these things, and you can do fine. Okay, this class is not that hard unless you don't have much time for it, and then it can be very hard and very, very stressful. So if you can allocate enough hours to this class, everything should go smoothly as long as you start early. The later you start and the less time you have, the more problems you're going to have. Have a decent late model laptop. Don't use a netbook. You really want a lot of pixels. Okay, pixels are key to acquiring complex, insights into the nature of a program and programming, a module or a class or a function. Okay, if you don't have many pixels, if you're staring at some little tiny piece of a class, 10 lines, and the thing is 1,500 lines long, there's going to be a lot of scrolling, and it's going to be way harder to keep it in your head. Okay, so don't try to program like on your phone. All right, get a reasonable 15-inch laptop. I have a 27-inch cinema display plus a laptop screen, and I use every pixel of it when I do programming. Okay, grading wise, 50% programming, 30% quizzes, 20% the final. There may be a midterm, in which case that'll be in there. That could, that's tentative. It could change. The percentages could change over the nature of the course of the course, but it'll be something like that. What I will not change is that if you have 90 to 100% of the points in the class, you're going to definitely get an A. 80 to 89, you're definitely going to get a B. I'll only revise that downward so that maybe 85% will guarantee an A if it's the case that I'm grading harder than I anticipate. Most of the lectures, in fact all the lectures, are going to be available online as a screencast, and then in the class time we're going to be having basically labs where you work together on the assignments, get a start on them. This is the classic kind of flipped classroom technology. And the main way this works is if you've always listened to the lectures, read all the links and so forth before you come to class. Okay? If you haven't done that, then the class is useless. Then you're partnered up with somebody and you can't contribute effectively to the conversation, and that person gets mad at you. So the way that I try to help incentivize you to keep up with the material is through quickie quizzes. So what I do each week is I release the modules that are going to be covered during the following week, and once those have been put on the schedule, then the day that module is listed on the schedule is the day you should have completed looking at all the resources, and that's the day when I can have a quickie quiz, which is just a very short 5-minute quiz to assess whether or not you've actually looked at the material. I'm also going to have you develop an engineering log in the class, which helps you acquire proficiency with technical writing. It also creates a demonstration of the concepts that you've learned in the class, which can be helpful to you when trying to demonstrate to future employers that you understand various concepts. Okay, and that's part of an overall idea of a professional persona, something I want you to develop in this class, which is, when people in the professional community look at you, how do they find you? What do they see when they find you? And does that adequately and helpfully represent your capabilities in the professional world? Just a quick note on collaboration versus cheating. I want to encourage a lot of collaboration in this class, but essentially cheating means when you submit somebody else's code as your own, okay? Or somebody else's work, I guess. You could copy a engineering log entry or something like that. So don't do that. You can always talk to people. You can have them look over your shoulder. You can tell them, they can help you debug an error or review an assignment. But all the typing should be your own. And in the rare cases where you may find a little snippet of code online and want to incorporate it in your program, you should do that, but then you have to add a comment explaining exactly where you got this code and why you have permission to use it. So you have to look at the licensing associated with whatever that code was, or contact the author of the code and make sure that they agree to have you incorporate that. Okay? As long as you're completely upfront about when you're using somebody else's code and tell me that proactively, like before it's due, then you can't be cheating, because you're not trying to pull a fast one over me. Okay? There may be cases where you say, I want to do X and Y, I want to use this or that, and I'll say, no, I don't want you to do that for whatever reason. You're going to have to go some different path. But that's fine. That's not cheating. That's just trying to find common ground on how to work through the material in the class. Okay, so I haven't had problems with this in a long time. I hope I don't have problems with that this semester. Again, I want you to acquire the material. I want you to work with others and feel comfortable with it, and just use common sense. And if you have a question, then just be upfront with me and we will work it out. Okay, so people say a lot of things about this class. Here's some student comments you can read through. One of the lessons learned is start early. Don't wait to the last minute, as I said before. Another lesson learned is that testing is actually a good thing. When you're doing it, you might think that it's just kind of redundant and so forth, but actually learning how to test can be very helpful to you. Reading code, learning how to look at other people's code, understand it quickly, and apply the high-level insights to what you're doing is an important feature of this class, and students really like that. They also find that standards are really useful, particularly for group work, because once you have a standard, you're looking at someone else's code. It's laid out the same way you lay out your own code, and you can read it and understand it much more quickly. Some students find they need to suspend their disbelief. They're skeptical about some of the things that happen in this class, and most of the time, maybe not all the time, but at least most of the time, they find out in the end that the material was actually useful to them. So hopefully you know, at least for 4 months, you can just try to kind of go along with this and see whether or not it's actually finally useful to you. Best case scenario is someone was, you know, confused about ICS software engineering, and I helped clarify all that for them. Worst case scenario, this person just could not handle the class. They didn't like me. They just wanted to Google things, and you know, I hope this isn't your experience. I definitely try to add value over Google to your life, and all I can say is I'm trying. Okay, so go to the calendar, find out when the modules are due, find out when assignments are due. As I said before, the day that a module is listed in the calendar is the day you should have already looked at all the material associated with it, and so it's now a valid quickie quiz topic. Okay, look through the website, start working on the modules, have fun, and I'll see you soon.